It is the unseen skeleton of our modern world, a surface so common it becomes almost invisible. Each year, global production surges past 10 billion square meters, a tide of material sufficient to line the walls of millions of homes, from the United States to Europe. This unassuming panel has quietly cemented its place as the backbone of modern construction. But behind this simple facade lies an intricate industrial journey. The transformation of raw minerals into the finished sheets we see every day reveals exactly how this material is made and why it has become the leading choice for builders across the globe. It is a simple sandwich of dust and paper, yet it has come to define the very structure of the modern home. Used in over 95% of residences across the United States, drywall is the ubiquitous choice for interior walls and ceilings. The composition of each panel begins with a core of finely ground gypsum powder, which is then compressed with immense pressure between two sheets of durable industrial paper. This unique combination yields a panel that is remarkably lightweight, inherently fire-resistant, and offers superior sound insulation compared to many older materials. In the American market, a standard 4x8-foot sheet typically carries a price tag between $10 and $20. Although its initial cost may be slightly higher than basic wood or plastic paneling, the speed of its installation and minimal upkeep ultimately make it a more economical choice over the life of a building. Before it can become a wall in a home, it must first be torn from the earth. The journey begins deep within vast mountain ranges, where deposits of gypsum lie hidden, accessible only by carving colossal open-pit mines into the landscape. Powerful drills are the first to break the silence, boring shafts dozens of meters deep into the rock. These channels are then packed with precisely designed mining charges. At the supervisor's signal, a controlled detonation erupts, sending thousands of tons of raw gypsum crashing free from the mountainside. This carefully calculated blast releases the mineral, preparing it for the next stage of its transformation. Massive excavators descend upon the piles of freshly blasted stone, their buckets scooping up chunks weighing several tons at a time. Each machine works in a steady rhythm, loading the mineral into the beds of smaller, specialized trucks that navigate the dusty mine paths to a temporary staging area. Here, the cargo is transferred once more, this time into giant, heavy-duty haulers built for immense volumes. From this point, the raw stone begins its long journey to the processing plant, where it will be transformed from a mineral into a material essential for construction. It all begins not with a whisper, but with the thunder of falling rock. A steady convoy of trucks delivers its cargo to the plant's receiving area, each one hauling several dozen tons of raw gypsum. The stone is dumped into a vast storage yard adjacent to the primary processing line, a sprawling landscape of raw potential. Here, engineers track the incoming volume and direct the flow of material, preparing it for the first stage of its transformation. On an average day, this facility will process the contents of more than 100 trucks, feeding thousands of tons of gypsum into the production system. From the towering piles, excavators scoop up massive loads in a steady, powerful rhythm, depositing the mineral into the production line's feed hopper. The large chunks are then conveyed onward, destined for the giant crushers that await them. This initial breakdown reduces the rocks to smaller, more manageable pieces, a crucial step that prepares them for the drying process to come. Inside the machine, immense force is applied with mechanical precision. The crusher utilizes two massive, constantly turning rollers that exert heavy pressure on the rocks fed between them. Large chunks are gripped and fractured, breaking apart into smaller fragments under the uniform force. This steady, relentless motion ensures that the crushing energy is used efficiently, maximizing the effectiveness of the size reduction. The result is a continuous stream of crushed gypsum pouring from the machine's base. These rocks, containing as much as 70 to 80% pure gypsum, are systematically reduced to particles just a few millimeters in diameter. This violent process, however, generates an enormous amount of fine dust. If inhaled by workers over long periods, this airborne particulate can lead to serious health conditions, including lung cancer. From mechanical force to elemental fire, the transformation now accelerates. Once ground, the gypsum is carried deep into the plant on a network of massive conveyor belts. Stretching for hundreds of meters, these belts run non-stop, their steady pace ensuring an uninterrupted flow of material to the next station. This automated transport system delivers every particle directly to the drying area for the next phase of its journey. Here, the fine powder is fed into a giant rotary kiln. Within the kiln, a chemical metamorphosis takes place. The intense heat causes the calcium sulfate to hydrate to slowly lose its water molecules, transforming it into calcium sulfate hemihydrate, more commonly known as calcined gypsum. Flames from a burner blast directly into the chamber, raising temperatures from around 300 degrees to over 660 degrees. The heating process lasts for hours, a deliberate pace that allows water to be released gradually, preserving the material's crystal structure. Engineers meticulously monitor the kiln's controls, maintaining precise temperatures across different zones. This strict oversight is the key to producing a high-quality gypsum powder, which is now ready for the mixing stage. Before thousands of tons are committed, a single small sample holds the key. After the heating process, the powder is sent to the mixing area to be prepared into a slurry. Technicians first divert a small amount to the laboratory for rigorous testing. There, the powder is blended with water in a precise ratio, along with additives like starch or setting time modifiers. The resulting mixture is thoroughly stirred and then closely monitored for its expansion, strength, and setting time. These results are then compared against exacting quality standards, allowing engineers to confirm the stability of the entire production lot. This critical testing step ensures that only gypsum meeting the highest level of reliability proceeds to mass production. Once the formula is approved, an automated system begins blending the powder with water and additives in the exact, predetermined ratio. Each batch of raw material is rapidly converted into a thick, uniform slurry, poised for the molding process. A fragile core of stone needs a skin of paper to give it strength. Drywall is not merely gypsum powder. It is a composite material, tightly sandwiched between two layers of paperboard that provide strength and prevent warping. To this end, massive rolls of paper, hundreds of meters long, are fed into the production line. Specialized machinery carefully unrolls and flattens the paper, ensuring its surface remains smooth and free of any creases. Operators remain vigilant, constantly adjusting the speed and tension to maintain perfect alignment with the rest of the line. This paper layer serves as the crucial framework for the panel, giving the gypsum a solid base to bond with. Immediately following this, the gypsum slurry is powerfully sprayed onto the flattened paper surface. High-speed nozzles distribute the slurry in a continuous, even layer, forging a tight bond between the core and its paper skin, laying the foundation for the finished panel. The panel is still a fluid mass, but its final form is now being forged. The continuous sheet of slurry-coated paper passes through a massive roller system, which sets its precise thickness. These rollers turn at a steady speed, applying light, controlled pressure to the surface of the mixture. This action levels the entire gypsum layer evenly from edge to edge, ensuring perfect uniformity. The thickness of a standard drywall sheet typically ranges from 9 to 15 millimeters, depending on the specific product being manufactured. Right after the layer is flattened, an automated system mists a thin solution across its surface. This fine spray is designed to eliminate tiny air bubbles that may have formed during mixing. If left untreated, these microbubbles could create voids, weakening the final panel structure. The solution is typically filtered water, sometimes enhanced with additives to improve adhesion. This controlled spray ensures the product maintains a uniform structure and a smoother surface finish. From here, specialized machines precisely shape the panel's edges, creating clean, even outlines that will make installation seamless. A river of white becomes a series of perfectly measured islands. As the fully formed panel continues along the conveyor, it enters an automatic cutting area. Here, sensors measure the length of the continuous sheet and trigger industrial blades to drop in perfect synchronization. The sharp, continuously running blades slice the panels into standard lengths, such as 2.4 meters or 3 meters, based on production requirements. This advanced system guarantees that every panel meets consistent quality standards. The next step is crucial for the panel's integrity. A mechanical system uses lifting arms and automatic guides to precisely fold the paper edges over, tightly encasing the gypsum core. This paper wrapping forms a sturdy, protective cover that holds the gypsum in place and guards the surface against cracks. Without this layer, the core would be brittle and crumble easily. At the same time, the paper creates a smooth finished surface, ideal for painting or tiling. Now the formed panels are moved into a massive drying chamber to remove all remaining moisture from the core. Inside, the temperature is carefully maintained between approximately 300 and over 660 degrees Celsius, with each drying cycle lasting around 30 minutes. Hot air is distributed evenly across all levels of the chamber, ensuring every panel dries consistently from the inside out, giving it the necessary hardness and strength for its final journey. The final touches are applied, turning a product into a brand. Once the panels are fully dry and stable, they proceed to an edge sealing line. Here, machines apply special paper strips along the sides of each panel, simultaneously protecting the edges and reinforcing their strength. These paper rolls are pre-printed with logos, product details, and technical standards, ensuring brand consistency across the entire batch. This process not only prevents chipping during transport, but also provides clear manufacturer recognition. From the sealing line, forklifts carry stacks of finished drywall into a vast storage area, where they are arranged in towering, neatly organized blocks. This efficient system allows for the storage of thousands of panels, ready to fulfill large orders, while also making the loading process faster and safer. When an order is placed, forklifts load each batch onto specialized trucks. From there, a fleet departs the plant, delivering the finished panels to distributors and construction sites across the market. From the chaos of the factory floor to the quiet walls of a home, the journey is complete. Once they leave the factory, drywall panels are valued for being lightweight, durable, and quick to install. In the United States, more than 90% of modern homes use drywall for their interior walls and ceilings. With a cost of just a few dollars for a standard sheet, its affordability has made it a popular choice. This combination of convenience and economy has established drywall as an almost indispensable material in modern construction. It lines the walls of our homes for decades, only to be reborn from its own dust. Across Europe, this cycle is a common practice, where drywall panels enjoy a lifespan of 30 to 50 years before a building's demolition. Rather than being sent to a landfill, the material is carefully collected for recycling. Workers dismantle and sort each piece, giving it a new purpose in the world of sustainable construction. From demolition sites, the salvaged material is transported to specialized recycling plants, with monthly volumes reaching tens of thousands of tons. This recycled gypsum costs 2 to 3 times less than what is freshly extracted from quarries. Remarkably, the material can be recycled up to 10 times while retaining nearly all of its original quality, representing a massive leap in resource efficiency. The transformation begins as the old panels are hoisted into the jaws of industrial crushers, where they are pulverized into a fine, consistent powder. From this point, the granular material moves on to further processing, preparing it to become the raw ingredient for entirely new drywall sheets. A key advancement in European facilities is the ability to integrate recycled paper into the panels. This technique not only strengthens the final product's bond, but also dramatically reduces the demand for mined raw materials. The paper, sourced from industrial and household waste, is meticulously sorted to remove all impurities, creating a building material that is both durable and environmentally sound when combined with the gypsum. Next, the recycled gypsum and processed paper are fed into a modern mixing system. These core components are blended with water and a handful of additives to enhance bonding strength, creating a uniform slurry. This viscous mixture is then poured out in a wide, soft layer, ready to be pressed and formed into new panels. A series of rollers and flattening systems gradually compress the layer, forcing out excess air and smoothing its surface. Automated blades then trim the sheet to a precise thickness, ensuring uniformity from end to end. As it travels along the conveyors, the material is pressed and leveled several more times, solidifying into a continuous, unbroken sheet. This long ribbon of drywall is then fed into an automatic cutting machine, where blades descend with perfect timing to divide it into panels of a standard size. The process runs without interruption, ensuring every sheet is identical. Finally, the finished panels are neatly stacked into large bundles, and automatic packers wrap the edges to protect them during transport, ensuring they arrive at their destination flat, intact, and free from damage. It is a material of paradox, built for permanence, yet designed for renewal. Its journey from the Americas to Europe placed it in most modern homes, where it holds a surprising capacity for rebirth. The panels can be recycled many times over, a cycle that greatly eases the environmental burden. What seems at first to be a simple surface, in fact, carries a long story of technological advancement and sustainable design.